Hello, my name is Hayden Lawson. Today I'll be joined by Jessica Eyerman, Tony Park, and Peiyin Tsay. We are representing Iron Wolf Cybersecurity, and we're here today to discuss SecurePyChat with you. It is a secure Python-based instant messenger. Today we'll be discussing what is SecurePyChat, going over a quick demo and code review of the application, why use it, how is it applied cryptography, future additions we plan to make, and discuss some lessons learned and different points within the conclusion, and provide you access to the resources we used and our GitHub repository. So what is SecurePyChat? SecurePyChat is Iron Wolf Cybersecurity's submission to the United States Marine Corps' first Network Battalion Annual Coding Challenge. In it, we're attempting to find a replacement for the currently used JabberChat. SecurePyChat is a Python-based end-to-end encrypted chat application that utilizes the Vignere cipher.
Today we'll be demoing our SecurePyChat application. You need two Python files to run this application, a server and a client. First, you want to run your server. Server is up and waiting for connection. Then you want to open a client. Running the client opens a GUI for your user to use. First, they want to pick a username to join the server, and the server sends a welcome message. Now I'll open a second client. And I'll name that user 2. It sends a welcome to user 2 and lets the first user know that another user has joined. Every time that a new user joins, all clients that are currently connected to the server will get a message telling them who has joined the chat. The way that the clients handle the traffic is the client sends an encrypted message to the server decrypts, analyzes, and then sends an encrypted message to all client users. For this application, we used a Vignere cipher for educational purposes. I'll show some traffic between the two. And there you go. During our demo, we were running Wireshark in the background to capture the traffic between the clients and the server. This is our PCAP file that shows the traffic from the demo. Now you want to put a filter in, and we'll filter down our data. Now this is to show that the messages are in fact encrypted. Each of these is a message either from the server to the clients or as a client message being sent via the server. Now here you can see this is one of the messages that has been encrypted. Now you can easily see that this is a sentence. In some of these other ones there are still punctuation. That makes it even more apparent that it is a message. Like we said in the demo earlier, we chose a Vignere cipher to show, so it was easier to show the encryption in our packet traces for educational purposes only. In a real-world situation, our SecurePyChat application would be using the most recent industry accepted encryption algorithms rather than the Vignere cipher.
In this section, we will talk about the server Vignere Pi code specifically. For all other code for the SecurePyChat application, please check out our GitHub repository. We'll link it in the description. Starting from the top of the code, we have our objects that are declared, right? We have a key Turing, as well as the letters we use for the cipher, A through Z. We have the information we supply to be able to connect to the server, as well as the clients. We have the code that supplies the logic of how to decrypt and encrypt the message right here. Here's the one for encrypting. Then we have some code to send all the messages to the clients that are connected. We have some code to handle the clients. And it also shows the welcome messages that you would see when you joined. And lastly, at the bottom, we have some code that we want to use for the future, which is to implement SecurePyChat through Heroku or another hosting platform.
So why use SecurePyChat? The tool offers end-to-end encryption for all messages using the Vignere cipher. This end-to-end encryption ensures only you and the person you're communicating with are able to read what is sent and no in between. Not even Eyerman Security can decrypt your messages.
Section 5. How is this applied cryptography? SecurePyChat, via its cryptography, ensures the confidentiality and integrity of both data in transit and data at rest. Use of Vignere cipher for educational purposes. Encrypted messages are easily recognizable through Wireshark packet capture. It's able to view encrypted data in PCAP. In a real application, a strong encryption like AES would make it extremely difficult to decipher.
So future additions we want to add to SecurePyChat include a different package from Tkinter. Tkinter is a package that we needed to display the chat rooms to our users. This package conflicts with Flask, which is an engine that could put our application online. And we noted multiple issues with Tkinter on Stack Overflow. Other additions we want to add: multi-chat room capability, single sign-on so you could use services like Google, stronger encryption like AES-256, and because this is a project we want to put more on the web and applicable to multiple OSs, we want to try different engines like React. In conclusion, SecurePyChat is an encrypted instant messaging application. It uses Python, which is a popular programming language, and any user can look at our GitHub repository to understand the inner workings of the code. We created this application to provide a solution to the Marine Corps for a replacement for Jabber Chat. Additionally, this application can be scaled in the future to incorporate more users via different engines like React. Lastly, there's applied cryptography in SecurePyChat because it encrypts all messages sent to and from the server.